Hi everyone. Today's lesson is going to be on area of parallelograms. So if we're going to be finding area of parallelograms, we should probably know what a parallelogram is. So here is the definition. What is a parallelogram? Well, it is a four-sided figure with opposite sides parallel and equal in length. Now, there's sort of vocabulary within the vocabulary because now what does this word parallel mean? So let's talk about that. So what does parallel mean? Well, parallel means side by side and always has same distance between them. Now you might be thinking, well, what's them? Well, you could have two markers that are parallel. They're side by side, and they maintain the same distance between them. So these would be parallel. You can see that the distance across remains intact, so that would make those parallel. Now, parallelograms you already know. Believe it or not, you've been dealing with parallelograms for a while now, such as squares and rectangles. So the reason squares and rectangles are parallelograms is because their opposite sides run side by side, always the same distance between them. So opposite sides are parallel. It's a four-sided figure. Opposite sides are parallel and equal in length. So we're going to actually focus on the rectangle for a moment, and we're going to review how we find area of a rectangle. So I'm going to change one thing on you today. Normally, we call this side right here length. Today, I'm going to ask you to call it base. And normally in a rectangle, we call this side width. Today, I'm going to ask you to call it height. And it kind of makes sense because base is like bottom. This is the base. And how tall something is the height. So base and height. Replace length and width. Okay, so when we find the area of a rectangle, normally we take length times width. Well, today we're going to say we take base times height. And we're going to use this little tidbit in just a minute. Okay, moving on. What is, ta-da, the area of a parallelogram? Well, guess what? The area of a parallelogram is the same formula as the area of a rectangle. Base times height. Remember length times width, but we're going to call it base times height today. What? The question is why? So next we're going to look at why that is true. So let's take a look at my next slide. So check out this parallelogram. We have parallelogram A, B, C, D. Notice the opposite sides are equal in length and the opposite sides are parallel. They maintain the same distance between them throughout the entire figure. So one thing I want to look at is what's the base and what's the height of this parallelogram? Well, if we look, it looks like the segment from B to C is going to be my base. And then it's like, well, wait a minute, what's my height? Well, let's look at the definition of the height of a parallelogram. It's the perpendicular distance between the base side and its parallel side opposite that base. So here's another vocab word, perpendicular. So when two segments are perpendicular, it means that they meet at a 90-degree angle. So I'm going to draw you the height of this parallelogram. So I'm going to basically go from one base to the next, and I'm going to draw this dashed segment. And do you see how it meets the base at a 90-degree angle? So that segment is the perpendicular distance between the base side and the parallel side opposite that base. Okay, so this is going to be our height. Okay, great. Now, why is the area the base times the height? I mean, it still doesn't quite make sense to me. Well, what I'm going to do next is I'm going to highlight this right triangle we've created. See this little triangle here? We created when we drew the height in. Okay. In my next picture, I am quite literally going to pick up this right triangle and I'm going to move it over here to this side. So watch what's going to happen. I'm going to pick him up and I'm going to move him here. If you notice, he's the same dimensions. We still have, I think he was originally 2 in base. Well, this distance here was 2, and this distance was 2. So if you look over here, I have it on the right side, 2 and 2. Okay, so that means that this part right here, like from here over, this is no longer here. It's gone. I clipped that out and I moved it over here. So now let's check out what I have. I have what shape? I have this, I have this, I have this side, and I have this side. What shape did I make when I moved that triangle over to the right? Is this a rectangle? I think it is. So rectangles have area length times width, but now of course we're calling it, remember we're calling that base and height. So now the area is base times height. That's the rectangle. Therefore, the area of a parallelogram, which had base and height, is the same as the area of a rectangle. So if you're a Y person, that is the reason why that works. Okay, so now let's get into some examples. So we have 2 examples left in this video. Here's the first example. It says, find the area of the parallelogram that you see right here. So pretty simple. So if you check it out, first thing you're going to do is you're going to come off, get my green pen, to the side. Let's just write down the formula for area of a parallelogram. We know it's base times height. And now we're just going to fill in our numbers. So let's find the length of the base. It looks like my base is right here and it's 6 centimeters long. So we'll put 6 centimeters times. And you see my height drawn here. My height runs straight up and down here so that it creates that 90-degree angle with the base. So it's the distance from base to base, and it's got to create that 90-degree angle. So that's labeled as 4 centimeters. So I'm going to put 4 centimeters over here for height. Notice they gave us this 5, but it's sort of to distract us. We never really need this length here. We just don't need it in the formula for area, so we're going to ignore that. And now we're just going to go ahead and multiply 6 centimeters times 4 centimeters, and that is 24 centimeters squared. Final answer. So finding area of parallelograms is actually pretty easy once you know where that formula comes from. Okay, final example, example 2. It says, if the area of a parallelogram is 64 square inches and the base is 4 inches, find the height. So no picture is drawn, but I do know they're talking about area of a parallelogram. So the first thing I'm going to do is write down my formula, area equals base times height. And I'm going to go ahead and fill in the numbers for the letters that I know. So first they tell me that the area is 64 square inches. So where the area is, I'm going to put 64. Then my equal sign. They also tell me that my base is 4 inches. So where the B is, I'm going to put 4. And then I'm going to bring down my H. Now we know that when two variables or a number in a variable are being multiplied, I can actually delete that time sign and just write 4H. It means the same thing. And now it looks like I have a one-step equation to solve. To solve for height, which is what I'm looking for, find the height, I'm going to draw that vertical line. And I'm going to do the opposite operation that is currently being done right now with the 4 and the H. So the opposite of multiplication is division. So I'm going to divide both sides of the equation by 4. 4 divided by 4 is 1, so those will fall out. Final answer, H equals 64 divided by 4 is 16. And then I'll put my units on. Height would be measured in inches in this problem. So height is 16 inches. So there you have it, just a little lesson on parallelograms.